Now, before we go into the mathematical part of what does it mean by a parallel vector, I have a question for you here, which is two workers are pulling a sled together using ropes that make the same angle with the ground. The first worker pulls with a force B is equal to 4I plus 3J. The second worker pulls in the same direction with a force R is equal to K times 4I plus 3J. If the total net force needed to just move the sled is 50 Newton, find the value of K. Okay, so this is a numerical for you. And I think by the very wordings of it, you should be able to, by this time you would be able to figure out that this question is based on parallel vectors. Although it doesn't say it explicitly. Right? Now, moving on to the mathematical part of this. So what does parallel vector means? Two vectors are parallel if they point in the same or exactly opposite direction. This means their direction ratios or the direction cosines are the same. So if B is equal to 4I plus 3J and R is parallel to B, then R must be a scaled version of B. Now what does scaled version of B imply? It means that the scaled version R could be 0.5 times B or could be longer than B, 2 times B, shorter like this, could be longer like this, same length, so same length as of B. Oh yeah, of course, this represents B here. This represents the shorter version, and this may be the reversed one. This represents the same length, and this here represents the longer version. So this is what parallel vector means. But in every case, R lies along the same line as B. So this is R, this as well, same as this. In all these cases, R lies in the same line as B. Okay. Now, what is the general rule for parallel vectors? So if B is equal to AI plus BJ, and if R is equal to K into AI plus BJ, where K is a scalar, which is a real number. So multiplying a vector by a scalar does not change its direction, only its length and sign, which means if it is positive, it's same direction, and if it is negative, it is reversed. So in this case, positive, same direction, negative, reversed. Okay. To make it more, just to generalize the mathematical part here, any vector parallel to B. Now this is where I would like you to make a note of this. Okay, only this section. Any vector parallel to B must look like R is equal to K times vector AI plus BJ, where AI plus BJ actually represents vector B. If K is greater than 0, R points in the same direction as B. If K is less than 0, means negative, R points in the opposite direction as B. If K is equal to 0, which becomes a special case, which is something we will reserve for future discussions. Now, if we get a question in the upcoming JEE mains, which will ask you to check if two questions are parallel, or maybe statement-based question like that, what do? A is equal to A1I plus B1J, B is equal to A2I plus B2J. Vector A is parallel to vector B only if vector A can be expressed as some K, scalar K times B. In a different way, A1 by A2 if is equal to B1 by B2, if these direction ratios are equal, provided denominators are not zero, which means we are not talking about a zero vector or a vector with a zero component. If A1 by A2 is equal to B1 by B2, if these direction ratios are equal, then the given vectors are parallel. Say for instance, A is equal to 4i plus 6j, B is equal to 2i plus 3j, 4 by 2 is 2, 6 by 3 is 2. So A1 by A2 is equal to B1 by B2. The direction ratios are same and yes, therefore they are parallel. Okay. Now coming back to the question, two workers are pulling a sled together. Okay, I didn't put up the visualization to you, right? Give me a second. Let's just visualize what the scenario is about. So this is what we're trying to say. There are two workers who are trying to pull this sled here. And if you visualize this as a free body diagram here, this is the sled here, which has been pulled by one worker, the red vector here, and has been assisted by another one who is pulling the same rope. The question is, what should be the magnitude of K to just move the sled? Yes, some of us might find this word tricky. Just move. Don't worry, we have upcoming discussions on friction, and then we'll understand what is the significance of this word just move. Okay, so this is what we're trying to understand here. Okay, and how do we solve the question? Let's have a quick recap of that as well. So the total force here would be the sum of these two forces, which actually is vector B plus K times, my bad, K times vector B, which is actually equal to 1 plus K times vector B. What is written here? So the magnitude of the new vector would be V is equal to 1 plus K into 4i plus 3j. So V will be equal to 1 plus K into 4 plus 1 plus K into 3, and magnitude of V would therefore be equal to 1 plus K into 5. 1 plus K into 5. It is given to us in the question that this magnitude is 50, therefore 1 plus K into 5 is 50 and K is equal to 9. What is the practical meaning of this value K is equal to 9? It implies that the second worker must apply 9 times the first worker's force, but in the same direction. To do what? To just move the block. Okay. Well, it's not a tricky explanation. It's a very simple and a straightforward one. But I would say, spend your time, think of this. Why is this question coming up in this chapter, motion in a plane? Is there any connection between any of the topics that we have learned so far, or maybe in the future? And if there is, could there be a possibility of question coming up in the coming JE mains based on this, right? Why? That's the reason why we are practicing PYQs. Okay, moving on to the next one.